Welcome to the MOOCs course Mechanical Unit Operations. In last couple of modules we have seen flow path solid object, especially different flow regimes, Stokes and Newton's flow regimes. Then also we have seen flow through packed beds and then fluidized beds. And then for corresponding cases we have also developed a kind of working principles, equations which describe these kind of processes, how to calculate the drag coefficient if it is a kind of single particle, how to calculate the pressure drop if it is a kind of flow through packed bed, and how to calculate the minimum fluidization velocity, etc., or the bed expansion if it is a kind of flow through fluidized bed. Those kind of thing we have seen. We have also seen a settling of a kind of particle in centrifugal field, etc. So why we have seen? Because we realized that in many mechanical unit operations it is not only solid phases interacting, solid liquid phases also interacts in general. So the having information or the having the fluid particle kinematics is going to be very much useful in designing or controlling the operating conditions of a several type of mechanical unit operations where solid fluid phases are interacting. So now what we do from this module onwards or from this lecture onwards, we are going to apply the principles of fluid particle interactions, whatever we have seen for single particle, packed beds and then fluidized beds, etc. Those principles we are going to use for some kind of realistic mechanical unit operations. Okay. So let us start with a kind of a process, filtration, where we can use the principles of packed bed, whatever we have derived previously. Those principles we can apply here and then try to develop working principles for this filtration processes, etc. Right. So directly before going into the principles of filtration processes, it is better to go into some basics of the filtration processes. So that is what we are going to see. So the title of this lecture is the filtration. So what is filtration? Is simply in normal terminology, if you wanted to say, it is a kind of separation of particles from a slurry or from a solution containing solids by using a kind of filter medium, so that you can have a kind of clear or almost clear liquid as a kind of filtrate, and then solids may be retained on a kind of filtration medium or filter medium. Okay. So that is simply a kind of filtration process, but applying such simple principles in industries will bring in several complications in kind of design and then operating of such kind of equipment. So those things we are going to see anyway. So filtration is a process where separation of solids from a suspension by passing it through a porous filtering medium or septum on which solids are deposited, whereas the fluid passes through as a kind of a clear filtrate. Okay. And in general this fluid can be a gas or liquid. It is not necessary that it is always a kind of a slurry from which you are separating solids, but it is sometimes also the filtration process is used to separate a kind of particles from dust laden gases, etc. So fluid can also be a gas as well, not necessarily it should be liquid always in this kind of filtration processes. Then suspension, it is not necessary that suspension may be having 50%, 60% of solids in general. It may have a kind of few traces also. So whatever the slurry or the dust laden gases that you take for separation of particles from those fluids, that particles may be varying a few traces, a very small concentration like few traces. It can also have a kind of high loading as a kind of 40%, 50% solids in a kind of a given slurry, something like that. Either of extremes are possible. In general, in between of these extremes anything can be possible. So basically these filtration processes can be used for the system where the particles are very few percentages to particles having very high loading as well. And then in general, when you do the separation, by using this filtration process, when you separate these slurry or dust laden gases into particles and then fluid as a separate, sometimes both clear fluid obtained and solids retained on a filter medium can be valuable products. Sometimes only one of them may be valuable product, another may not be valuable product. And then sometimes both of them may not be a kind of valuable product, something like wastewater disposal. So, wastewater disposal from the industry you cannot dispose as it is because of the pollution control. So, what you do, you do that wastewater treatment and then try to separate the solids from the liquid, and then whatever the clear or almost clear liquid is there, that you can let it go, that you can discard separately, and then solids you can discard separately as per a kind of pollution control board regulation. As per the pollution control board regulations, then you can discard liquids and then solids separately if both of them are not a kind of useful products. Then filtration is in general is not as convenient as it looks like, simple separation of solids by using a filter medium, but in general it may come across several kind of inherent difficulties, because of which filtration may not be processing conveniently, or the efficiency of the process may not be sufficient enough. In such cases, in general, some kind of pre-treatment is carried out. Pre-treatment, something like heating or recrystallizing of the slurry before separation, because sometimes what happens, if you have a kind of very fine particle in the slurry, so then they may be clogging the filter medium pores, and then that may be gradually forming a kind of impervious cake on the filter medium because of these fine particles, and then further filtration may not take place. So, but if you such kind of slurry, what you do, if you can recrystallize it, then these particles, finer particles may be form into a kind of bigger particles within the suspensions, like that, as we have seen a kind of one of the size enlargement processes. So, that way once the particles will become bigger size particles, then these particles may not form a kind of impervious cake kind of thing, and then filtration may not be, or rate of filtration may not be diminishing with time. So, that is the reason maybe recrystallization should also be taken as a kind of a pre-treatment. Or sometimes what happens, you can add a kind of a filter aid. Filter aids are in a kind of two types. You can add some material, some kind of filter aids to the slurry before the separation, or you can have a kind of layer or a pre-coating layer on the filter medium before you bring in the slurry for separation onto the filter medium. Right. So, either of the way the filter medium filter aids are used. So, adding a filter aid, etc., these kind of processes in general enhance the efficiency or the separation rate of the solids from the slurries by filtration. Right. Further, there are kind of different types of material to be separated in general, both particle size, shape, and then surface characteristics of the particles, etc. Those many inherent details are in general going to affect the filtration process. Sometimes the variety of wide range of operating conditions you may also be applying for a kind of filtration. So, because of such reasons, many types of filters have been developed in the industry or in the literature, and then which are oftenly used in industries as well. Then how the filtration takes place, though it is a kind of simple separation, seems like simple separation of a solid from a slurry by passing through that slurry through a filter medium. But how this separation takes place in generally? So, that takes place because of the pressure difference across the filter medium that we use. Across the filter medium there would be a kind of pressure difference would be developed, and because of that pressure difference the separation takes place. Let us say if you have a kind of filter medium onto which you have taken a slurry, you are not applying any kind of additional force, pressure force, or centrifugal force, or blowers, etc., nothing you are using. Then what happens, whatever the required delta P is there for separation to occur, that is because of the pressure, that is the column of slurry, that liquid column or slurry column, whatever it is giving that pressure may be acting as a kind of a pressure, required pressure for the separation to occur. Okay, though in such cases the filtration or the rate of filtrate may not be sufficiently large enough. So, basically whether you apply the external force or not, the filtration is taking place because of the pressure difference that is developed across the filter medium, right. So, because of that reasons, the filters are in general classified as a kind of the filters which operate with atmospheric pressure on the upstream side of the filter medium, and the filters which operate with an atmospheric pressure on the upstream, but with a kind of vacuum at the downstream side of the filter medium. Okay. These two ways one can classify these filters based on the pressure difference that has been developed across the filter medium. Sometimes having atmospheric pressure in the upstream side of the filter medium may not be sufficient to have a kind of required filtrate rate. So, in such case in general what you need to do, you need to increase the pressure above the atmospheric pressures. So, how you can do that? You can do simply by the force of gravity acting on a column of liquid, or by using some pumps, or by blowers, or by centrifugal forces. Now, we see the gravity filters. In general we might have seen kind of separation or the cleaning of water through allowing it to passing through a kind of bed of sand in general. So, by you take a bed of sand and then you allow the liquid that or the water that you wanted to be clean it. So, what you do that that whatever the bed of sand through which you allow the water, right, and then water to pass through the bed of this sand, so that whatever the coarse particles etc. are there in the liquid or water, that would be retained by the bed of sand, and then clear water can be taken at the bed. That is a kind of simplest case one can see as a kind of gravity filters. So, in the gravity filters, filter medium can be no finer than a coarse grain or a bed of coarse particles and something like sand. So, because of these reasons, their application in the industry is in generally restricted. Why? Because this the filter medium is a kind of just a kind of coarse grain or a kind of bed of coarse particles like sand, where you can retain only the coarse particles are there in the kind of a solution whatever are there, right. So, that is because their application is limited because of this reason. So, industrial applications are also restricted in general to draining of liquor from very coarse crystals, or clarification of potable water, or treatment of wastewater etc. Now, coming to the industrial filters in general they operate either in a continuous mode or in a kind of batch mode, right. So, but whether it is continuous mode or batch mode, the force that is applied for filtration to occur is going to play a kind of vital role on the performance or degree of the separation. Okay. So, that is the reason, based on the force that is applied for this filtration to occur, these industrial filters are in general classified as three types. One is the kind of pressure filters, another is the kind of vacuum filters, and third one is in the kind of centrifugal filters or centrifugal separators. Now, we see what happens in batch or discontinuous filters. In general, when a filtration process is going through, or the cycle is the filtration cycle is in under operational conditions, the solids form as a kind of layer on the filter medium, right. And then if you do not remove them, then the in general filtrate the flow rate of filtrate will gradually diminish. Or sometimes it is also possible, if the particles are slimy or very fine particles, then they may be forming a kind of impervious cake. So, because of which the further filtration may not take place. So, for that this filtration cake has to be separated periodically, right. So, if you stop the filtration cycle so that you can separate this filter cake whatever formed on the filter medium, then such kind of processes are known as the batch or discontinuous filtration process, in which during operating cycle flow of fluid through the device is continuous. However, it is periodically interrupted so that to permit discharging of accumulated solids. But in the continuous filtration process, what happens? Not only this flow of filtrate is continuous, but the whatever the cake form is there, discharging of that cake is also continuous during the operation of the cycle. So, you will not stop the process intermediately just for the cleaning the in order to discharge the solid cake whatever is formed. So, in the continuous filtration, discharge of both solids and then fluid is in general uninterrupted as long as equipment is in operational condition. So, this is the simple difference between continuous and batch filtration processes, right. So, there are many filtration equipment are there which operate either batch wise or continuous wise. There are also some equipment which operate in both continuous as well as batch mode. So, under each of the above three types of filters, that is based on the force applied for separation to occur, that is we have the pressure filters, vacuum filters and centrifugal filters. There exist several designs of industrial filtration equipment which may operate in continuous or batch mode, right. However, the details of such equipment we are going to study in the subsequent lectures. We are not going to go through those industrial equipment right through, because before going into the details of filtration theory or principles of filtration and then industrial equipment used for the filtration, it is much more important to know some basics about the filtration mechanism, filtration aid or requirement of the filtration medium or filtration septum whatever used, what are the requirements, what are the kinds of filtration aids etc. are available. Those information, general information kind of things are kind of essential. So, first we go and see those details before going into the principles of filtration processes and equipment used for the filtration processes. So, now based on the filtration mechanism, the mechanism that has been used for filtration, these filters are in general classified into three types. Okay. One is the cake filters, another one is the clarifying filters and then third one is the cross flow filters. We see a few details of each of them right now and then we see the details of each of them in subsequent lectures. So, principles of cake filters and then principles of cross flow filters we are going to see later on, but at the end of this lecture we will be discussing principles of clarifying filters. So, what happens in cake filters? Cake filters in general relatively large amounts of solids as a cake of crystals or sludge are separated by cake filters, where schematically if you see you have a kind of filter medium here like this, which may be having a kind of porous structure, not necessarily a kind of linear or channel kind of porous structure as shown here, but there may be a kind of interconnections of porous structures may also possible. So, onto this filter medium, the slurry is allowed to through this filter medium, slurry is allowed to pass through in a kind of a direction normal to the filter surface. Normal to the filter surface, this slurry is allowed to pass through this filter medium. Okay. So, that clear liquid or filtrate can be collected at the bottom. It may be clear or almost clear, not necessarily that it should be completely free from particles. There will definitely be a few particles in general, because these are used for large amounts of solids as a cake, crystals or sludge. Okay. So, whatever the particles, bigger particles are there or intermediate particles are there in the slurry, they will be forming a kind of a cake on the surface of this filter medium. So, that is the reason these filtration processes are in general known as the cake filters, right. So, if these cakes are removed from the filter medium by interrupting the process, then that process we can call it as a kind of batch process. But if you have a mechanism in your design such a way that this cake is also periodically or continuously removed as it is formed on the solid object by scraping it by a knife or something like that, then such kind of process is known as a continuous process, where the collection of filtrate as well as the discharging of solids are continuously taking place. However, we are going to see those details later on in equipment part anyway. Right here, they include provisions for washing cake and removing of liquid from solids before discharge. We see more details of cake filters later on, especially their working principles, etc., and then what kind of equipment that we have, industrial equipment we have which operate, where the cake formation is a kind of primary important thing. Those kind of things we are going to see in the subsequent lectures anyway. So, the next one is the clarifying filters. Clarifying filters in general, they remove small amounts of solids to produce a clean gas or sparkling clear liquids such as beverages. So, if the cake filtration is separating large amount of coarse particles, clarifying filters are separating the small amount of particles which are there in a kind of gases as dust laden gases, or a kind of some beverages liquid where we have a small amount of particles. So, then those small amount of particles can be removed by these clarifying filters. Okay. So, particles are in general trapped inside filter medium or on its external surface. Okay. So, basically this filter medium here, it is not like a simple filter cloth that you use for the kind of cake filtration, etc. Filter medium that are used for a kind of clarifying filters in general, a kind of pack or a kind of pad which is filled with a kind of cotton or cellulose pulp or glass fibers, etc. They are a kind of bed, as a kind of deep bed in general. So, whatever the suspension which is having small amount of solids, or gas which is carrying a few amount of solids which are allowed to interact with this bed or the pack of this cotton or cellulose pulp or glass fiber, such a way that these particles are trapped when they interact, when they strike on the surface of this filter medium. They will be sticking to the surface, or they may be partially blocking the porous structure of this pack whatever we have, right, and then leaving behind almost a clean liquid or a kind of gas if you are using this for dust laden gases, right. So, this is the in general principle here. So, what we see here, in general we can see that the pore structure of this bed or filter medium, which is now is a kind of bed, it is a kind of pack of cellulose pulp or glass fiber or cotton, etc. So, the porous structure, the pores are maybe in general much larger than the particle size. Whereas in the screens what happens, these the apertures should be of a size smaller than the particle size, so that the particles are retained on the screen. But here it is not like that. It is like the porous structure, the pores may be much larger than the particle size, and then this particles when come and then strike on the surface, the particles will be trapped on the surface and then later on they will be removed. So, that is the process, that is the principle of clarifying filter anyway. So, pores of filter medium are much larger in diameter than particles to be removed, unlike the screens in general. So, this is the basic thing about what is happening in clarifying filters. So, here impingement, a kind of a process which is causing a kind of separation. It is not the porous structure that is causing this separation to occur. The porous structure is there just which will allow the clean liquid or clean gas to pass through, but the particles which are striking onto the surface of these beds, they will definitely be sticking to the surface, because these particles anyway, the small amount, we use these clarifying filters for the cases where the liquids, the gases containing only small amount of solids. So, the small amount of solids will be striking onto the surface of the filter medium and sticking onto the surface of the filter medium, or they may be partially blocking the pores, okay, but they will not be able to pass through the deep bed of this filter medium, which is in general a kind of pack of cotton or cellulose pulp or glass fibers. Right. So, what is the difference between the cake filter and clarifying filter? Cake filters are in general used to separate large amount of coarse particles, whereas the clarifying filters are in general used to separate small amount of fine particles, smaller particles. Okay. Then on the other hand, cross flow filters, we have a kind of in cake filters, the flow the slurry is allowed to pass through the filter surface in the normal direction. If this is the filter surface in the normal direction, the slurry is allowed to pass through, so that the clear liquid is coming through the bottom and then solids are being retained. But in the case of cross flow filters, the slurry, the liquid that is containing the solids, that is coming at high speed, across the filter surface like this. Across the filter surface like this. So then whatever the particles are there, they deposit it on the surface, and then clear liquid is coming out from the bottom, as in general in a kind of membrane process, indeed in a kind of membrane processes only. So when these particles are forming on the depositing on the surface, they also kind of have a kind of tendency to form a kind of cake, something like that. But the relatively high velocity fluid, whatever it is coming, that will be carrying these particles to move forward in the flow direction, so that the surface is not accumulated by the particles, though there will be a kind of layer of particles forming a kind of concentration polarization kind of thing will form. So, but they will not allow to form a kind of cake. There will be a layer of particles deposited, but they will not be the high speed liquid that is coming at high speed, that will not allow to form or accumulate these solids to form a kind of a cake. They will only be a kind of few layers, which is also known as a kind of concentration polarization. That is what happens in cross flow filters. So, feed suspension flows under pressure at a fairly high velocity across the filter medium in cross flow filters, and thin layer of solids may form on the surface of medium, but high liquid velocity do not allow it to build up as a cake, right, like this. So, let us say we have a kind of a membrane surface or the filter medium now here in our terminology. So, which is nothing but a kind of membrane which may have a kind of a continuous pores without any interlocking. There may be interconnecting pores, something like this, okay, as shown here. So, all kind of pores are possible in general in membrane surface. So, what happens here, onto the surface, membrane surface, we allow a kind of suspension which is having particles to flow across the filter medium surface at relatively high velocities, so that particles would be in general deposited on these surfaces, on the surface of the membrane, and then a clear filtrate in general will be collected at the bottom. So, these particles, though they are depositing on the surface, the high speed of slurry or the liquid which are which is a kind of feed from which we are separating particles, that high speed will not allow this particle to form a kind of cake, etc. But though there will be a kind of a layer formation cannot be avoided in general, and thus such kind of layer of particles formed on the surface is known as a kind of a concentration polarization in membranes terminology anyway. So, the difference between the previous two methods and this method of filtration is, here we get clear, almost clear filtrate with almost free from solids as a one phase, but other phase you will not get a kind of a separate phase as a kind of solids. You will get a kind of a concentrated suspension, okay. So, which is known as the retentate. So, filtrate is also known as the permeate. Permeate is a kind of almost clear or almost clear liquid without any kind of solids, right. So, once you get this permeate out continuously, the solution that is retained on the membrane surface is in general a kind of a concentrated suspension. So, rather getting two separate phases as a kind of complete separation, here you get only one phase, almost pure phase like a liquid phase as a kind of almost clear permeate, whereas this remaining one is a kind of concentrated suspension. Let us say if you have a suspension, feed suspension, something like 100 ppm solution, then permeate you may get something like having 1 ppm or less than 1 ppm solution. So, whereas this retentate may be having a kind of 10 power 5 ppm or even higher ppm concentrated suspension you may get. okay. So, which is known as the kind of retentate. So, these numbers are just a kind of indicative, so that to explain, but not necessarily that they have a kind of real connection with the real situations, realistic problems. Okay. Now here we can see feed is 100 ppm and then retentate may be having 10 power 5 or even 10 power 10 ppm is also possible, not necessarily that, depending on the applications. Whereas the filtrate or clear permeate, in general we try to have a kind of a liquid which is having almost no solids, that is less than 1 ppm or something like that. So, these numbers are just to explain, not necessarily they represent the true picture of membrane suppression process in general. So, what kind of membranes in general used for this cross flow filtration? In general, they are ceramic, metal or polymeric membranes are used with pores small enough to exclude most of the suspended particles, right. So, such kind of membranes are in general used as a kind of filter medium under cross flow filters, and then portion of liquid passes through medium as a clear or almost clear filtrate, leaving a more concentrated suspension as a retentate. Example, in ultrafiltration, whatever the membrane is there, that is ultrafilter, and then this ultrafilter is a cross flow unit consisting a membrane with extremely small openings used for separation and concentration of colloidal particles and large molecules. Then filter medium, what kind of filter medium one should use in general? For most of the industrial applications, a common filter medium is a kind of canvas cloth. But if the slurry is kind of corrosive, or the liquid which you are treating for separation of the solids from that liquid, if that is a kind of corrosive, then in general wooden cloth, metal cloth, glass cloth or paper cloths are used as a kind of filter medium for such kind of corrosive liquids. Sometimes you need a kind of a chemically resistant filter medium, right. So, for a few applications, so then in such cases synthetic fabrics such as nylon, polypropylene or various types of polyesters can also be used as a kind of chemically resistant filters, right. Filtrate may first come through in general as a kind of turbid or cloudy liquid, but after initial stage, then we start getting almost a kind of clear filtrate. So, what we do, this initial turbid or cloudy filtrate that we get, that we send back, then cloudy filtrate is returned to the slurry tank for refiltration. Okay. Then requirements of septum or filter medium that we are in a kind of very much essential in kind of filtration process. There should be some kind of minimum duties that septum or filter medium should do. What are those requirements that you are expecting that filter medium or septum to fulfill for a given filtration process? Basically, the most important one is to retain solids, okay, retain solids to be filtered and provide acceptable clean filtrate. Acceptable clean filtrate, there are some kind of process where the volumetric flow rate of filtrate that is collected is in general very small, something like 10 power minus 3 meter cube per minute, something like that, such a kind of small filtrate. So, if the filtrate volumetric flow rate is such small, so that operation cannot be a kind of a feasible at industrial scale in general. So, because of that one, it is the filter medium or septum whatever we use, that not necessarily just retaining the solids, but they should also provide acceptable clear filtrate, and they should not plug or blind in general, otherwise filtration process may be disturbed. These septum should be chemically resistant and strong enough physically to withstand sometimes severe process conditions applied for a required separation processes. Sometimes you may be applying the pumps or blowers or centrifugal forces such a way that the delta P that is being generated, that may be in general very high, right. That is required for a given separation in general sometimes. Then whatever the septum that you take, that should be physically strong enough to withstand such kind of high pressures for filtration as well. Though very high pressures are not a kind of economically feasible anyway, and then should permit the cake form to discharge cleanly and completely, and should not be prohibitively expensive. They should not be very expensive, because if they are expensive, then overall process cost is going to increase anyway. So then filter aids, sometimes filtration process may be not happening or occurring to the expected level. So then one can use filter aids. These filter aids can be used in two ways. One is adding some kind of external material, external inert material to the slurry before filtration. That is one process, and other process is adding or forming a pre-coat layer on the filter medium before the start of the filtration process. Okay, either of them are possible. So in general, very fine or slimy solids often form a dense impermeable cake that can quickly plug any filter medium that is fine enough to retain such fines, right. Under such conditions, feasible filtration of such solids require that porosity of cake be increased to permit passage of liquor at a reasonable rate. So how that can be done? That can be done by adding a filter aid, which is in general inert, to slurry before the start of filtration process. So some examples of such kind of filter aid are diatomaceous silica, such as diatomaceous silica, perlite, purified wood cellulose, or any other inert porous solid which can enhance the filtration rate. Subsequently, filter aid may be separated from the filter cake by dissolving the solids or by burning out the filter aid. If both solids and then filter aid are of no use, then both of them can be discarded together. You do not need to separate filter aid. If your solids are a kind of important product, then you have to separate the filter aid from the solids that are being retained. Okay. If the solids are not important for any kind of application further, if they are simply to be discarded, then both the filter aid and then solid can be discarded together. So other way of filter aid is forming a kind of pre-coating layer on a kind of filter medium. So depositing a layer of aid on the filter medium before filtration is an alternative way of applying a filter aid. Pre-coat layer is in general thin in a kind of batch process, but if the filtration process is a kind of a continuous process, then layer of pre-coat is thick and then gradually becomes thicker and thicker as the filtration process progresses. However, top of layer is continually scraped off by an advancing knife to expose a fresh filtering surface in continuous process, because in continuous process you cannot afford to stop the process for clearing this cake. So you have a kind of advancing knife to scrap off these solid cakes that are formed on the filter medium, so that to expose fresh filtering surface for further separation of slurry. Pre-coat layer prevent gelatinous solids from plugging the filter medium and give a clear filtrate almost. Pre-coat obviously is a kind of part of filter medium. It is not part of the cake. It is part of the filter medium, because this pre-coat we are giving onto the as a kind of coating onto the filter medium. Okay, so it is a part of filter medium rather than of the cake. So now washing of filter cakes. Washing of filter cakes is also kind of very much important, even if the solids are not important for application point of view, because of pollution control board regulation also. Sometimes this washing of cake is a kind of very much essential. What happens after filtration processes? The filter cake is like a packed bed with void spaces filled with solutions. Whatever the cake that we have in general, like let us say after the filtration, whatever the cake that is formed, it is having this kind of packed bed structure in general, right. So it may be, this cake may be having a finite size LC in general. So here this these are the particles, but this is in a wet form. So, whatever the porous structure is there, that is being occupied by the solution. So, you need to wash this cake because of either importance of the solids or because of the any other reasons like pollution control reasons or or any other specific reason specific to given application. So, if cakes are not washed after filtration, what happens? The solute may be retained as impurities on the solid product after drying. So, sometimes washing is needed to recover valuable solutes so that they can be used or reused as well. So, often cakes are washed with water. In general, some cakes are also washed with solvent to remove solutes. If solid is a waste product, then also cakes are often washed prior to discharging due to pollution control regulations. Further, the rate of volume of wash liquid, that is volumetric flow rate of wash liquid that is used, along with the volume of the wash liquid are a kind of two important design parameters as well as the important parameter for controlling the operation of a filter. So, how much liquid should be used for a given washing of a cake, and then what volumetric flow rate this liquid should be used are going to be two important parameters for washing of filter cakes. So, let us see principles of washing cake filters. In general, as I already mentioned, this wet cake is having mostly solids, but the void spaces are in general occupied by a kind of solution, right. So, volume of wash liquid that is required to take off the solutes or completely nearly remove the solute, that is going to be much more higher than the volume of solution retained in that cake after filtration. Okay, that is volume of wash liquid required for nearly complete solute removal is in general much more higher than the volume of solution retained in the cake after filtration. Let us say if LC is cake thickness and then epsilon is the average porosity of the cake which you want to wash, and then A is the cross sectional area of the cake, then epsilon A LC is the volume of solution left in the cake. So, whatever the volume of wash liquid is there, that is going to be much more higher than this value epsilon A LC. Right. So, during first part of washing, there are several stages in washing. So, first stage is known as the displacement wash, where the wash liquid passes through the bed and just pushing the solution ahead of it, and solute concentration in exit stream equals the initial concentration of solute in filtrate in general. Pictorially, if you see, let us say washing filter cake. So, effluent concentration with respect to time, if you see this initial period, this period A, from this A location to B location, whatever the concentration you can see, it is almost constant, and then it is almost constant and it is equals to whatever the initial concentration of solute in the filtrate. So, initial this level is known as the displacement wash. Displacement wash, in this region what happens, whatever the liquid is there, wash liquid that you use, that will simply push the solution that is retained in the porous structure of the cake, and then that solution moves out. So, then when solution moves out, that effluent, in the effluent the concentration of the solids is almost initial concentration of solute in the filtrate. Once it is crossed here, so abruptly the concentration of the concentration in effluent, that abruptly drops to 0 almost like this. Okay. So, displacement wash can remove most of the solute with a minimum volume of wash liquid if the bed had uniform size and ideal plug flow with no axial dispersion. Then effluent concentration remained constant until all the solution was displaced by the wash liquid and then drop abruptly almost to 0 as I have shown in the picture. Right. Sometimes the void spaces in the cake are in pockets or in side channels where there is a little or no flow is occurring. So, removing the solution from there is in a kind of difficult. So, these still retain solute when the solution has been displaced from the main channels, because in those pockets or side channels there is little or no flow. So, it is not possible to remove them simply by displacement wash. Right. From the pockets, what happens, solute diffuses out into the main channels. Once what happens in from these pockets, because of the concentration difference, once the wash liquid is displacing the solution that is present in the void spaces, right. So, whatever the solute that are there in the pockets or side channels, they will be finding a kind of a concentration difference. Their concentration is high in these pockets or in pocket channels, whereas their concentration is very less in the kind of main channels or main void spaces, from where the solution has already been displaced with the wash liquid. So, there in the void spaces you have the wash liquid. Wash liquids are almost having no solutes. So, in the pockets, the side channels, whatever the solute are there, they experience a kind of concentration difference, and then because of that concentration difference, diffusion will start occurring, and because of the diffusion, those particles which are there in the pockets or in the side channels, they will come into the main channels, and then they will be carried away along with the wash liquids. Okay. From the pockets, solute diffuses into the main channels, and there is a rapid drop in effluent concentration, because there is only a few particles remaining in the pockets and then side channels. This diffusion stage in general starts when around 70 to 75% of the solution in the cake has been displaced by the wash liquid, just by the displacement stage. Additional hold up in pores and lower effective diffusivity prolong the diffusion stage for a bed of particles and require more wash volume for a given percentage of removal of solutes. So, from this point onwards, one should be very useful whether further washing cake is required or not, because from here it is going to take a more wash volume for a small percentage of removal of solutes, because majority of the solutes have already been removed. There are only a few solutes are there, right. So, one has to do a trade off such that the washing should not be going to be more costly compared to the value of the solutes that you are going to recover, right. So, washing should be stopped when the value of unrecovered solute is less than the cost of recovering it. Okay. So, this is about the principles of washing filter cakes. Now, we see a few things about clarifying filters. Clarifying filters, as I said, it is by a kind of impingement of particles on the filter medium, and then filter medium used for this clarifying filters are in general a kind of packed or pads which are filled with cotton, cellulose pulp, or glass fibers, etc. They are kind of deep bed. Okay. So, when the slurry containing small amount solids or dust laden gases come and interact with this pad of glass fiber or cellulose, etc., the particles will stick onto the surface, and then the clean gas or liquid will pass through the filter medium. So, these particles may be separately removed later on anyway. So, in the clarifying filters, these remove small amounts of solids or liquid droplets from either liquids or gases. Okay. So, usually they are used when the concentration or only a few traces of solids are present, or small amount of solids are present in the liquid or gases, then only in general we use these clarifying filters. Separation occurs as particles are trapped inside the filter medium or on its surface, and in general they differ from screening such a way that pores in filter medium are larger in general, as I already discussed in one of the previous slides. This filter medium is a kind of bed of cotton or glass fiber, etc. So, the porous structure of this bed is in general larger than the particles, right. but however the separation is taking place when the particles are coming and hitting the surface by impingement, they stick to the surface and then liquid can be passing through clearly. Whereas in screens, the aperture opening has to be smaller than the particle size so that the particles can be retained on the screen. So that is the difference between these in general screens and then clarifying filters. This whatever the clarifying filters, the pores are there, sometimes they may be much larger than the particles to be removed. However, despite of that one, separation takes place, almost complete separation takes place because of the deep bed of this pack of this filter medium that we use. In these filters, particles are caught by surface forces and immobilized on the surfaces or within the flow channels, and they reduce effective diameter of channels, but usually do not block them completely. So, there are some principles of clarifications that we can see here. Direct sieving is the one. In this, solids are being removed would completely plug pores of filter medium, and rate of plugging is constant with time, but in general such kind of completely plugging the porous structure of the filter medium is not experienced, which is a very rarely encountered in general. So, the standard blocking where the commonly particles partially block the pores, giving a gradual reduction in the pore size. And then in cleaning of gases, mostly the separation is done by impingement of particles against a solid surface placed in the flowing stream as shown in a figure here. So, we are discussing principles of impingement here, pictorially we can see here. So, now let us say this is a kind of a surface, filter medium, okay. This is a kind of filter medium which is a kind of pack of cotton or glass fiber or cellulose pulp, etc. Okay. So, now here a fluid carrying particles coming with a velocity u naught, right. So, then the fluid will have a kind of streamlines like the solid lines shown here like this, right, like this, okay. The solid lines whatever are shown are a kind of in general streamlines that you find in general like this when we have like this when a fluid is flowing across a object like this. Now, object I have taken as a kind of a circular one here for easy understanding, right. But this what is to be observed is that the velocity u naught velocity is there, that is for the particles, and then this liquid whatever is there, or the dust laden gases whatever are there. So, then because of inertia of the particles, they deviate from the streamlines, right. This particles, path line of particles in general deviate from the streamlines as shown as a kind of dotted lines here, right, because the inertia is higher compared to the kind of fluid for a gas or liquid, right. So, then when because of this inertial their higher inertia, these particles strike onto the surface of this filter medium and being separated. So, initially whatever the particles that are whatever the things like this between this AB line are there. So, whatever the particles are there, they will be striking onto the surface and then may be separated, and they do not need to be re-entered, okay. Whereas the gases or the particle laden gases which are moving away from these A and B locations, they may not be able to separate it because they are not having a kind of interaction with a kind of a filter medium here. So, particles because of their inertia are expected to cross the streamlines of fluid and strike and adhere to solid, from where they can subsequently be removed. Particles initially moving along streamlines between A and B strike solid filter medium and can be removed if they adhere to wall and are not re-entrained again because they are already separated. Particles initially following streamlines outside lines A and B do not strike the solid and cannot be removed. So, the efficiency is a kind of factor. So, The target efficiency is defined as the fraction of particles in the gas stream directly approaching the separator element that strike the solid and being striking onto the surface of this filter medium. So, only those fraction of solids which are striking onto the filter medium, that fraction of solid material is known as the kind of target efficiency, right, because the particles which are not striking onto the filter medium, they are not being separated. Okay. So, that is the basic way or the best possible way to define the target efficiency for this kind of filter medium. So, what is the target efficiency? It is the fraction of particles in the gas stream directly approaching the separator element that strike the solid and being adhered to the solid surface or filter medium, which can be separated subsequently or removed subsequently. But overall collection efficiency is different from the target efficiency, and this overall collection efficiency depends on different things. One is the target efficiency, the other one is the solid fraction of the filter and the depth of the filter bed that has been used. Okay. So, even when target efficiency is not very high, nearly complete removal of particles can be accomplished by using deep bed of fibers to give repeated chances of particle interception. What we have this filter medium as a kind of, as I mentioned, they are pack or a kind of pad with cotton or glass fibers or cellulose pulp, etc. If this pad, if you can have a kind of deeper one, right, deep bed of pad if you have, then it is possible that repeated interception of these particles with the filter medium will take place, and then separation efficiency will increase, right. So, generally tiny droplets move across the streamlines by diffusion and are immobilized on the solid surfaces. And since diffusion is more and more effective as particles become smaller, target efficiency is also correspondingly increases. So, this is about some basic principles of the clarifying filters. In the next lecture, we will be discussing the working principles of cake filters. The reference for this lecture is McCabe-Smith and Harriet, that is the textbook Unit Operations of Chemical Engineering by McCabe, Smith and Harriet. That is the reference book that I have used for preparation of this entire lecture. However, some details can also be found in about the filtration in these other reference books, like Unit Operations of Particulate Solids, Theory and Practice by Ortega Rivas. Then Carlson and Richardson's Chemical Engineering, second volume by Richardson and Harker. Then Transport Processes and Unit Operations by John Copleys, and then Unit Operations by Brown et al. And finally Introduction to Chemical Engineering by Badger and Banchero. Thank you.